In this demo, we will show how ChipStack helps engineers verify a design using both simulation and formal verification, all from one integrated environment. We are currently inside the project folder. This folder contains the RTL design files, specifications, and any other design-related documents. The user launches ChipStack and opens the TUI. From there, the user simply types "Verify this design using UVM and simulation." ChipStack's orchestrator takes this high-level instruction and starts breaking it into steps. First, ChipStack studies the design. It reads the RTL and available specifications, understands the design intent, the interfaces, the behavior, and the corner cases. From this, it creates what we call a mental model of the design. Once the design is understood, the orchestrator calls the UVM coding agent. The UVM agent automatically creates a complete UVM test bench for the design. It generates the required UVM components, the environment, sequences, agents, monitors, drivers, and scoreboarding logic. It also creates the file list needed to compile the design and the test bench. Next, ChipStack runs Xcelium Simulator. If there are compile or runtime issues, the agent analyzes the errors, fixes the generated code, and reruns the tool until the test bench can compile and run successfully. Here, you can see the folders and files that ChipStack created automatically. The file list includes all the required RTL and test bench files. The generated UVM code is readable, well-documented, and self-contained. The test bench includes all the key components needed to start simulation-based verification. Now, let's verify the same design using formal verification. The user goes back to the TUI and types, "Verify this design using formal verification." The ChipStack superagent takes this instruction and starts the formal flow. Again, it begins by building a mental model of the design. Then it creates a formal test plan. After that, it generates the formal test bench, assertions, assumptions, and tool scripts required to run Jasper. ChipStack then runs the formal tool, reviews the results, and performs auto-correction when needed. If there are failures or tool issues, the agent analyzes them, updates the artifacts, and reruns the flow. At the end, ChipStack provides all the generated artifacts needed to run Jasper Formal, including the test plan, formal code, scripts, and result summaries. ChipStack also provides a visual UI where users can review the generated artifacts and give feedback. In the UI, the user can inspect the mental model, the design hierarchy, and the generated verification plan. For formal verification, the UI shows each test point, the code generated for that test point, the result of each run, and debug information for failures. The same integrated experience is available for simulation as well. Users can review the generated UVM test bench, inspect simulation results, view waveforms, and quickly debug failures directly inside the ChipStack environment. The key point is that ChipStack is not just generating code. It is deeply integrated with EDA tools like Jasper Formal and Xcelium Simulator. It understands the design, creates the verification plan, generates the test bench, runs the tools, analyzes the results, fixes issues, and presents everything in one place. This gives verification engineers a single environment to move from design understanding to UVM simulation, formal verification, debug, and artifact review. ChipStack brings together AI agents, design understanding, and EDA tool integration to make chip verification faster, more automated, and easier to manage.